Hi, welcome to my video on evaluating limits by factoring. So, the limit as x approaches 2 of x plus 1 times x minus 2 divided by x minus 2. So if you put 2 in here, you get a 0. Put 2 in here, you get a 0. And you get a 3, so 3 times 0 is 0, so you get 0 over 0. So, it's what they call it indeterminate. So what we do, we notice that x minus 2 is common here, so we cross that out. So we have the limit as x approaches 2 on x plus 1. So since the x minus 2 cancels out, we got to be careful. If x minus 2 equals 0, so that means x is 2. So when x is 2, the numerator and denominator becomes 0. So after we cancel the x minus 2 out, we have to put 2 back in. So as it approaches 2 now, we get 2 plus 1, which is 3. So that's the point when x is 2, y is 3. So really, what we have, if you think about it, you have a line which is y equals x plus 1. The y-intercept is 1, and the slope is 1 over 1, so you're up 1, right 1, up 1, right 1. So that's the line that represents y equals x plus 1. But the point, since we crossed out x minus 2, we're crossing out or leaving out the point 2, 3. So 2 gives me a 3, so x is 2, y is 3. So let's say that's right there. And that point is not there. There's a hole in this line. Because we crossed out x minus 2, we're leaving out where x is 2, so we're omitting the point 2, 3. So there's a hole. So this point 2, so this is the line, except the value of x is 2. When x is 2, y is 3, so there's a hole in this line. And when you graph, you won't see that hole. So you can zero in on or zoom in on this point 2, 3, and you'll see it. Number 2, what about the limit of this rational expression as x approaches negative 1? Again, negative 1 will give you 0 here, and a negative 1 will give you a 0 here if you plug it in. So what we have to do is that we have to see if we can factor. So x squared is x and x. Factors of 2 are 2 and 1. Product is negative 2. Sum is negative 1. So that's a negative 2 plus 1 when we factor over x plus 1. And what happens is the x plus 1's cancel out. So we get the limit of x approaches negative 1 on x minus 2. And again, x plus 1, so x plus 1 equals 0, so x is negative 1. So if you evaluate this simplified rational expression, then as you put negative 1 in, you get a negative 1 minus 2, you get negative 3. So again, that's the point. When x is negative 1, y is negative 3. So the limit of this expression is negative 3, but again, it's a hole that's in this line. So this is the line y equals x minus 2. So on this line, this hole, there'll be a hole at negative 1, negative 3. And number 3, the limit as x approaches 4 for this rational expression. And let's see if we can, if you put 4 here, you get 16. Put 4 here, you get negative 16, you get a 0. Put 4 here, you get a 0, 0 over 0. So let's see if we can factor. So we take, in denominator, we got x as a GCF. We take x out, we get x minus 4. That means the x minus 4's cancel out. So we get the limit of x goes to 4, and that's a 1 over x. So Now we can sub the 4 in. So that's 1 over 4. So the limit is 1/4. So that means that the limit is 1/4. So we have, when x is 4, we have a 1/4 limit. The limit is 1/4, which means on this 1 over x, you got a vertical asymptote. So if you think about it, you have a vertical asymptote at x is 0. So look right here, we got x times x minus 4 equals 0. So x is 0, or x plus 4 equals 0. So you have vertical asymptotes at x equals 0, which is right there. You have a vertical asymptote at x equals 4, which is right there. So, but possible vertical asymptotes, because the x minus 4 cancels out, that gives you 0. But because they cancel out, that means the x equals 4 is not. We would think by making it equal to 0, making the denominator 0, we're going to get vertical asymptotes. No. So this is not a vertical asymptote at 4, because the x minus 4 factor cancel out. 4 is gone, so the only vertical asymptote is at x equals 0. So the point 4, 1/4, which is this point right here, that's the point that is hollow. That point of 4, 1/4 is a hollow on this graph. If you draw the graph, that point will not be there. So if you put 1 in here, when x is 1, y is 1. If you put 2 in here, when x is 2, y is a half. So this is going like this, coming over, hitting this point, and going on through. But this point 4, 1/4 is not there. Again, you put 4 in, you'll get a 1/4. But this point 4, 1/4 is not on this graph. So again, the limit is 1/4 at 4, but this point is not there, and it's not a vertical asymptote because it's canceled out. And if you go to the other side and pick up -1, when you put in a -1 for x, x is -1, y is -1, so that's right there. So this part of the graph goes like this and this. So there's one side of the graph going towards x equals 0 asymptote. This is the right side going to infinity. This is the left side going to -infinity. And again, as x gets larger and larger, 1 over x goes to 0. So this goes to positive infinity, going to 0. Right there, positive goes, x goes to positive infinity, y will go to 0. As x goes to -infinity, y goes to 0 here. Okay, let's continue. And let's do some more. The limit, again, this is a rational expression. If we're approaching -2, putting a -2 in here will give me a 0 on the bottom, so that's 4. Minus 6 plus 2 is 0. Putting -2 here, we get -6 plus 6 is 0. So the limit of, we have to think, can we factor? So I see a 3 common on the top, 3 outside of x plus 2. On the bottom I got a quadratic, hopefully it's x and x, factorable, 2 and 1. Product is 2, sum is 3, so it's got to be 2 pluses. So the x plus 2's cancel out, so I got the limit as x approaches -2, and that's 3 over x plus 1. And the limit, as you put a -2 in here, you get 3 over -2 plus 1. That's 3 over -1, so the limit is -3. Because the limit is -3, we also think of, that's the point. So, and the point, again, where we crossed out at x's plus 2, if you make it equal to 0, we're looking at it at -2. So when x is -2, y is -3. So the limit of this function is -3. That means on this graph of, if you let y equal this or f of x equal this, on this graph you will have this function with a vertical asymptote of -1, and the point -2, -3 will be hollow, will not be on the graph. And number 5, we have another one, but this time we get a cubic and a linear. It's limit at 1, so let's see. Put 1 in here, you get 0. You put a 1 in here, and you get 0. Just try it. So that means we have to try to factor. So the limit, and look at the bottom, I see 2 common, I see a -2. So take the -2 out of both of these, you get x minus 1. Now, the top part of this, I'm going to factor this fully down here so I won't waste space. Right here, we got 3 terms, cubic, so I'm going to take the x squared out of the first two. I'm going to do it by grouping. X squared is an x plus 1. And in the next two, I see a -1, so I take the -1 out, and I'll get an x plus 1. So x plus 1 is common, GCF, and I get an x squared minus 1. So that's x plus 1. X squared different to 2 squares, so that's an x and an x plus 1 minus 1. So that's x plus 1 squared times x minus 1. So this is x plus 1 squared times x minus 1. And again, you can see that the x minus 1 cancels out top and bottom. So this is the limit as x goes to 1. So as x approaches 1, we have x plus 1 squared over -2. So plug the 1 in, so we get 1 plus 1 squared over -2. 2 squared over -2, that's 4 over -2, which is -2. So the limit of this function is -2. Again, I did a little bit different factoring here in this cubic by grouping. And this is a binomial with a -2 common, so it canceled out. So we're looking at x minus 1 equals 0. So we're looking at, again, where x is 1. And so the limit here is -2. Again, if you graph this function, which is right here, this is really, if you think of this, just look at it, this is 1 negative 1/2 x plus 1 all squared. So that's a parabola whose vertex is -1, 0. So this is a parabola whose vertex is -1, 0. So the vertex is -1, right here, 0. And the parabola is going down. So there, I'm just doing a rough sketch. There it is. So we're looking at the point, when x is 1, y is -2. So x is 1, y is -2. That's that point there. So this point is a hollow point. X is, oops, sorry, not that point there. X is 1, y is -2. There's the point. Sorry about that. 1, -2 is right there. So this is 1, -2. So this point is hollow. So really what we have is a parabola with this hollow point. This point is not on this graph. So it's a parabola without the point 1, -2. Again, the limit is -2, but we cancel out x minus 1. So we're omitting the value where x is 1. So on this graph, or on this rational function, we have the point 1, -2 being omitted. So that brings us to the end of just different ways to evaluate limits and using different strategies. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.